All right, let's jump right in. Today, we're going to talk about a challenge that's been on the factory floor pretty much forever. That gap between how a part is designed and how it actually gets made. We're going to look at a really smart plugin for SOLIDWORKS CAM called Tolerance-Based Machining, or TBM, and it promises to close that gap for good.
You see, in just about any manufacturing setup, there's this classic disconnect. It's really a tale of two different worlds. You've got the design engineer on one side and the CNC machinist on the other. And even though they're both focused on the same part, they're coming at it with completely different goals.
So the designer, they're thinking all about the part's purpose, its fit, its form, its function. This means they often use what we call asymmetric tolerances. But the machinist, they need to program their machine with a single, precise, middle-of-the-road number, a mean value. And right there, that's the translation gap. It's a gap that's usually bridged by hand, which, as you can imagine, opens up a huge door for mistakes and wasted time.
And this is exactly where tolerance-based machining enters the picture. You can think of TBM as the missing link, the bridge that connects those two worlds. It's like a smart translator that was built specifically to solve the exact problem we just talked about, and it does it automatically.
So what is this thing, really? Well, TBM is a plugin. It plugs right into SOLIDWORKS CAM, and it reads all that critical info a designer embeds in the 3D model. We're talking dimensions, we're talking tolerance ranges, and even the required surface finish. It gobbles up all that data and then uses it to automatically figure out the absolute best way to machine the part.
And this part right here, this is its superpower. TBM automatically takes those design-focused, sometimes tricky, asymmetric tolerances and just converts them. It turns them into the exact mean tolerances that the machinist needs to get the job done right. It does all the math, so the machinist doesn't have to. That old conflict? Gone. The chance for human error? Dramatically reduced.
So you're probably wondering, how does this actually work? It might sound pretty complex, but TBM pulls it off with a surprisingly simple, automated three-step process. It's not really magic, of course. It's just some very, very elegant software at work.
So here's how it goes down. First, the designer uses a tool inside SOLIDWORKS called DimExpert. They use it to annotate the model with all the crucial product manufacturing information, or PMI. Think of this as embedding the part's manufacturing DNA right into the digital file. Second, the software's automatic feature recognition scans the part and finds all the machinable features, the holes, pockets, slots, the whole shebang. And then third, TBM puts it all together, reads that PMI for every single feature, and instantly assigns the right machining strategy.
But how smart is it really? I mean, does it just use a one-size-fits-all approach for everything? Not a chance. The real power here, the secret sauce, is its ability to make decisions based on context. It actually understands what the designer intended.
And this is where it gets really cool. Take a look at this. For a simple, standard hole with a pretty loose tolerance, TBM might just say, okay, easy. We'll center drill, then drill, done. But if it sees a critical hole, one that needs a very, very tight tolerance, it knows that's not enough. So it automatically adds more steps, like reaming or boring, to make sure it hits that higher standard. So you see, TBM doesn't just automate, it optimizes.
Okay, so we've seen the problem, and we've seen TBM's really smart solution. But what does this all mean in the real world? What's the actual payoff on the shop floor? This is where we go from a cool idea to some serious, tangible efficiency.
Let's just ask the most important question you can ask about any new tech. What does this mean for the people actually doing the work? How does this make the day-to-day job of making things any better?
Well, the benefits are huge, and they show up almost immediately. You're talking about a massive reduction in CNC programming time. That old back-and-forth conflict between design and manufacturing, it's gone. Parts get machined to the required mean tolerance first time. It all adds up to some pretty incredible efficiency gains, and it supports everything from 2.5 access to multi-surface features. It just works.
Really, it all boils down to this one powerful statement. This capability reduces CNC programming time and lets you efficiently machine parts that meet their required tolerances, period. It's the very definition of working smarter, not harder.
And that brings us to a final thought to leave you with. A tool like tolerance-based machining is fantastic for closing a gap that's existed for decades. It automates conversations that used to be manual, time-consuming, and full of errors. So the question is this: when we use this kind of smart automation to finally bridge those old divides, what new possibilities are we opening up? What can we start building tomorrow?